A parallel plate capacitor with air between the plates has a capacitance of 9 picofarad, right? The separation between the plates is D. The space between the plates is now filled with two dielectrics, right? One of the dielectrics has a dielectric constant 3 and thickness D by 3. Let us first of all draw it. This was basically the capacitor, right? Now it was having a thickness D, right? And D by 3, thickness D by 3 is filled with a dielectric. This dielectric K1 is equal to 3 and this dielectric is K2 equal to 6. This is what? D by 2D by 3, right? So basically we can convert this into two capacitors who are joined in series, obviously, right? This will let us name it as C1 and C2, right? So what will be first of all, initially what was given? 9 picofarad was when air was there in the plates initially. Initially what was happening? C was equal to A epsilon naught by D was equal to 9 picofarad, right? Now let us mark this as 1. Now afterwards there are two capacitors, right? C1 we can convert as A epsilon naught. How much is D? D by 3 basically. So 3 epsilon naught into K1. So this will be equal to 3 into K1 is 3 into A epsilon naught by D. This will be equal to 9 A epsilon naught by D, right? Now if I talk about C2, this will be equal to what? A epsilon naught into K2 upon 2D by 3, right? And K2 is 6, so that means it will also be 9 A epsilon naught upon D. Now these are in series, that means net C net is given by what? C1 C2 upon C1 plus C2, right? So I can take out A epsilon naught by D as common and write as 9 into 9 upon 18, right? So this will be equal to what? 9 by 2 into A epsilon naught upon D, and from 1 what was A epsilon naught by D? It was 9 picofarad, right? So that means this was 9 into 9 is 81 by 2 picofarad. That means 40.5 picofarad is the correct answer. So this was a basic concept. This was an easy concept. If you know about capacitors and dielectrics, this would have been a cakewalk for you, right?